Hi everyone, welcome back. We are going to continue with our grade 12 physics final exam. Yes, final exam is coming, so we must answer our questions. What I'm going to ask you, like always, please try first. I will give you 30 seconds for each question. I will try to read some questions, or you can read and you can try. 30 seconds for you. Today we are going to answer some multiple choice questions. 10 questions we are answering with you from 1.1 to 1.10. Question 1 is coming now. Question 1, 1.1. An object is moving to the left at constant velocity when a force Fx on it. Magnitude of frictional force acting on the object is 0, smaller than applied force, equal to F, larger than F. So your 30 seconds starts now. Please try. Always we should try first. An object is moving to the left at constant velocity. That point is important. Your time is getting 0. Now. Yes, 3, 2, and 1. Time is up. So, time's up. We will continue now. But if you need extra time, please stop me and carry on. So, how can you answer this question? We are looking for frictional force. But what we know object is moving at constant velocity. What does it mean, constant velocity? Constant velocity means acceleration equals 0. If acceleration is 0, and if I write Newton's second law, F net equals m times a. From Newton's second law, I'm going back to Newton's first law. F net equals 0. Friction force. What we know about friction force? Friction force always opposite direction of motion. So we have some important points. To get good mark, we have some important points. One important point for friction force, always opposite direction of motion. This object is going to the left direction of motion this way. So friction force going this way. Friction force, opposite direction of motion. And then we know F net equals 0. We are using Newton's first law. Why? Because object is moving with constant velocity. You can say this question is easy. Why you are keeping us for one question so long? We are trying to give you some important points. Because when you go to another question, they're going to change just something, small thing. But they're going to ask you small, that plus, minus, same stuff. F net equals 0. What's our F net? Always direction of motion, we are choosing positive. So F first. F minus, I'm writing F net now. F minus friction force equals 0. And then I can take friction force other side. F apply, F equals friction force. So our answer is equal to F. Done. What we know, at constant velocity, F net equals 0 because our acceleration is 0. Friction force, always opposite direction of motion. And you are writing Newton's second law or first law. If you use second law, you are going to write acceleration is 0, and then you are coming to Newton's first law straight. Or you can use from initial, you can use Newton's first law, and you can say F minus F equals 0 and calculate. Done. Question 1.1 done. Okay, let's continue with next one. The answer is C. Answer is just showing. After 30 seconds, maybe I can show answer straight. So next question is coming now. Question 1.2. Yes, let's start. Let's give you 30 seconds. This is our question. Apply force acting on X. And then they're asking you magnitude of the force on block Y by block X. So you are looking for force between X and Y. Options here. Please try. If in the extra time, you know what you're gonna do. Please try first. Yes, time is up. So how we are gonna calculate force on Y? Force on Y, we are gonna calculate now. So let's continue. First of all, we are using Newton's second law. F net equals, but what we know about this motion, let's check. F is applied, all right. Smooth surface, there's no friction force, okay. And if no friction, if applied force acting this way, so of course object is moving this way. And then accelerating, of course, because there's no friction force, there's no another force, of course object will accelerate and going to the right. So if I write my Newton's second law, F net equals m times a. This is our Newton's second law. But mass, not this mass, don't misunderstand, this is formula, just as m times a. But what mass we have, total mass, m plus m. F net equals m mass of x plus mass of y together times a. For this system, if you write Newton's second law for this system, you are writing like this. So, and then F net, what we have, apply force. Yes, we can write straight. We can write that one here. Let's write our apply force straight. Let's say F apply is equal to m plus m times a. I think this point is okay. And let's go to this way. We are looking for Fxy. So force on object y by block x, on block y by x. So Fxy, we are just calling like that. So Fxy equals, this force is equal to m times a. Why? Because this force pushing only object y, and mass of object y is m. So I'm looking for Fxy. But as you see, I have two equations. If I take this a alone with f, so can I write acceleration equals f over m plus m? All right. So we are just using this a here and then coming this side. So Fxy equals m times f over m plus m. So answer is Fxy equals mf, apply force, over m plus m. I think it's okay. Our answer is D. We said straight, we are going to show, but we couldn't do that. So first of all, you are writing Newton's second law for full system, and you are writing Newton's second law just for y. And then you are calculating acceleration from first equation, and then taking that acceleration, putting on Fxy, and you calculate your Fxy. I hope it is okay. Let's continue with next question. Answer is D. Now another question for you. So question 1.3. This one, let's see what they said. We have 4 planets here. 1, 2, 3, 4, 4. Yes, number 4. And then first mass m reduces r. Second one is mr. Other one is 4mr, 2r, 16m, 2r. And they're asking you which planet, so which one they have equal gravitational acceleration. So gravitational acceleration, we have a formula. So formula box, in formula box you can have it, but I can write it here for you. So G equals, let me write here, G equals capital G times M1 times M2 over R. So we are using this one, but, oh, sorry, not M1, M2, M1, M2 for all fours, just M. Okay. G times M over R squared. This is formula for gravitational force. This is constant number, G. You can get it in formula box. And mass is mass of planet. R is radius of planet. So you are using this formula for each, and and then you are going to say which one equal. 1, 3, 4 all equal, or 2, 3, 4 equal, or 1 and 2 equal, and 3 and 4 equal. Let's see. So you have time, 30 seconds, starting now. Let's give your 30 seconds. Yes, please try. Just write formula, gravitational acceleration formula, and getting your answer. The simple one. This question is okay. Other questions waiting for you? Other topics? Today we'll try to answer all topics, all physics topics, grade 12 physics topics, all multiple choice questions for you. Okay, time's up. Let's start. So, first of all, if you use, okay, let's use different colors now. First one, G equals formula, capital G, M over R squared. This is our first one. First planet gravitational acceleration. Second one, G equals G, capital G times 4M, because mass of, and then R squared. So this is second one. Can anything simplify? Nothing, all right. So this is our number 2 already here, okay. And next one, G is equal to capital G times 4M over 2R squared. So 2R squared is equal to 4R squared. So 2R squared equals 4R squared. So, and then 4 cancel each other. What we are getting, G times M over R squared, as you see, is equal to number 1. So 1 and 3, they are equal. Let's continue with next one. Next one is G equals capital G times 16M over also 2R. So 2R squared is equal to 4R squared. So you can write 4R and 16 over 4 is equal to 4. G times 4M over R squared. This one looks like number 2. As you see, it is here. Exactly the same. Let's draw here. So 2 and 4 also equal. Let's check. 1 and 3 equal. 2 and 4 equal. 1 and 3 and 2 and 4. So this is our answer, gravitational force. Let's continue with next question. I hope everything is clear so far. 3 questions we have done for you, but still we have 7 questions. Let's continue with next one. So answer is D. Yes, 1.4, projectile motion. This is easy one. They're asking you maximum momentum. Just we are taking object, going up from B to C and then coming down. Which position object has? Object just has maximum velocity. This object getting maximum momentum. Yes, velocity also important, but momentum. They're asking you momentum. Let's give your time. Okay, this time to try. I must keep quiet. Time. So you are looking for maximum momentum. Which point has maximum momentum? Please try. 1.4. This is about projectile motion and momentum together. So last 1 second. Yes, time is up. Our answer is, now let's show, answer is A. Why A? Because at point A you have maximum velocity. What was the formula for momentum? Momentum is equal to mass times velocity. If your velocity is maximum, your momentum also maximum. So this is our answer, point A. Because let's check. Let's say this is our initial velocity. Even you can give some numbers. Let's say 5 meters per second. If you start with 5 meters per second, then object is going to highest point. Velocity is 0. Change to 0 because highest, and then it's coming down. It's more than 5, maybe 6, 7, but more than 5. Let's say 7 meters per second. And then it is increasing when it's coming here, maybe 10 meters per second. It depends on time, of course, but just giving numbers just to see what's going on. Firstly, velocity decreasing from D to C, and then increasing from C to B, and then B to A also increasing. and the maximum velocity at point A, and then maximum momentum at point A also. If they ask you minimum momentum, point C. If they ask you maximum potential energy, what you are going to say? Maximum potential energy. Maybe next time they are going to ask you that question, who knows? Just they will ask you maximum potential energy at point C. You can say it is 0, but how it's maximum? Because potential energy depends on height. M times G times H. You don't need velocity for potential energy. I hope it's clear. So if they ask you maximum potential energy, you are just talking about height. So maximum height at point C. And the minimum potential energy at point A. Minimum potential energy. I'm shouting, sorry. Just like in the classroom. So point A, potential energy is highest potential energy at point C, minimum potential energy at point A, but maximum momentum at point A. Answer is A. Let's continue with next question. Question 1.5. Okay. If the momentum of an object is double, then kinetic energy of object is what? Your time starts now. You must just remember momentum and kinetic energy. Momentum and kinetic energy. So definition between momentum and kinetic energy, we should remember. Momentum formula and kinetic energy formula. Your time, yeah, you have time, last 5 seconds. Of course, if you need extra time, you can carry on, you can stop video and you can try. So time's up. So let's continue. Momentum double. If the momentum of an object is double, so momentum equals m times v, and then kinetic energy equals 1/2 times m times v squared. So if you double momentum, in this question, this past paper, when we check, they are giving you 2 options, B or D. If you change velocity, if you want to make double momentum, you must make double velocity. So if you make double velocity, it's going to be 2v. Okay, 2v. And then 2p is equal to m times 2v. So you are making double momentum, yes. And just write 2v here. So 1/2 times, not equal, 1/2 times m times 2v squared. And then 1/2 times m times 4v squared. So you can take 4 front. 4 times 1/2 times m times v squared. So we are making 4 times greater. This is our answer. But another option, they said double. Maybe they think change mass, just to make it double. Maybe you can just change mass, not velocity. Making double, just changing mass, because they didn't say that clean. Just to make it double momentum, you can make 2p is equal to 2mv, making double for mass. And if you make 2m here, so 1/2 times 2m times v squared. So you have only 2m, no square here. Just you can take 2 front, 1/2 times m times v squared. Now double. But I choose this one. This is best one, because objects changing mass, it means you are adding some extra stuff, extra particles. So changing objects. So I don't know about that one. But the answer is D. Let's say. Let's continue. So this is our question 1.5. Next question, work, energy, and power question. Which one is correct? We have 1, 2, 3 options. Which one is correct? Only 1, 1 and 2, 2 only, 1, 2, 3. Which one? Your time starts now. Please read question and try. You have 20, yeah, time is going. Let's continue. Question 1.6. Work is done on an object only when a force. Okay, let's check. Yes, time is going. So 3, 2, 1, and time's up. So, let's continue. All right. Work is done on an object only when a force is placed on object same direction. Just object displays the object in the direction of force. No, even different direction they are having, because just remember friction force, friction also making work, but opposite direction, negative direction, because you have on just object and you have applied force and friction force. Friction also doing doing work, but negative. So this option is not correct. Total mechanical energy is conserved only the absence of non-conservative force. Yes, without, because total mechanical energy is same if you don't have friction force. All right, so this one is correct. And the work done on an object by a net force is equal to the kinetic energy of the object. It looks correct, but forgetting about change here. Change in kinetic energy, change of kinetic energy. This is work energy theorem. So too many times they're asking this question. Work energy theorem is something like this, but we should say change in kinetic energy. Because of that, this option also not correct. Our answer is only 2. 2 only. Option is C. C is correct answer. So let's continue with next question. 1.7 is coming now. Let's give your 30 seconds now. This is Doppler effect, all about frequency, wavelength, velocity. A car is coming closer to listener, stationary listener, and asking you which one will not change. Which of the following properties of the sound waves heard by the listener will not change? Time is over. Okay, so what they ask you now, let's check question. A car is coming with noise, okay, with constant velocity, and then as car moves away, moves away, okay, going away, sorry, not coming, going away. So for this kind of question, for Doppler effect, we are using 2 points. First point, source of sound. Second one, listener. And then VL, we are saying velocity of listener is 0 for this one. And velocity of sound is equal to, we don't know, but that is going constant. And then we have Fs, we have Fl, and which of the following sound waves heard by? Okay, not real one. Which one just detecting from that? Which one heard by listener will not change. So we have a formula. Fl equals V, speed of sound, plus minus VL and V plus minus Vs times Fs. These are Doppler effect formula to calculate frequency. Why we are saying plus minus? This is general formula. Plus when it is coming closer, minus when it's going away. Now it is going away, so we are going to use this formula. Let's check. We are using Fl equals V minus VL and V plus Vs. VL, velocity of listener, Vs is velocity of source, and V, speed of sound, and times Fs. So which one will not change? Velocity, V listener already constant 0. Okay, by the listener will not change. So velocity will not change. Let's say that, because as you see, velocity, you are not calculating velocity, you are calculating frequency. So frequency getting different. If frequency getting different, option B is gone, option C is gone, option D is gone, because all of them, including velocity. All right, sorry, frequency. Oh, just all of them, including frequency. Because of that, if frequency change, wavelength also change. If frequency decreasing, wavelength increasing, you know that. So Doppler effect, object is going away. For Doppler effect, we remember our formula. This is our general formula. If it is going away, minus plus. So if it is coming closer, plus minus. Remember that. So let's continue with next one. Next question is 1.8. 1.8. This one is electrostatic question. Let's check question what they ask, and then we can give you 30 seconds. First of all, okay, 3 charged objects. We have P, Q, and R. Okay, on the system we see that Q is positively charged plus Q. Okay, so sphere Q and R distant from each other with D. All right, and R is negative Q. Okay, the magnitude of charge on sphere P is 9 times greater than that on sphere Q. Okay, it means P, QP is equal to 9Q. But we don't know positive or negative. All right, we'll decide about that because they said 9 times greater than that, but they didn't say negative or positive. Negative and positive, we'll work on it and we'll get it. Okay, let's see what they ask. For now, I think everything's okay. Which one of the following combinations of vectors will cause the net electrostatic force on object Q to be 0? Yes. Okay, we know charge of Q and R, so it means we can calculate force here. Let's say it is attracting each other, so just attracting force F R Q this way. And then if you want to get oh, sorry, I didn't give your time. Okay, sorry. Okay, your 30 seconds starts now. Forget about FRQ. Let me clear all. Yes, your time starts now. We are looking for, okay, we are looking for distance between P and Q and charge for P, sphere P. Please try. Yes, time is, yes, time's up. Okay, so now I can explain. So we have force on Q, name is F R Q, and we have to draw this way because we know F net equals 0 on Q. So F P Q this way. So if it is this way, if it's attracting Q, it is positive. What we know, positive and negative. So positive is gone. So we have negative charge. Attracting negative charge because attracting Q. How we know attracting? Because we are trying to get 0 charge. Okay, and what else we know? They are equal. So if they are equal, I'm going to use our formula. So K times Q charge of R times charge of Q and D square. How I am writing this? Because I know electrostatic force from Coulomb's law. Formula is K times Q1 times Q2 over R square or D square. It's fine, distance between them. By using that, I'm just writing this formula. So we can say K times Q square over D square, right? We can just write like this. And same stuff, same thing here. I'm just writing formula for FPQ. FPQ is equal to K times charge of P is 9Q. Okay, 9. Let's write 9, not Q. 9. Now I can write Q. 9Q. And charge of Q is Q. And it looks like 9 now. Sorry. And X square. So we know these two, they are equal. Okay, let's write here. K times, I'm writing FPQ first. K 9Q square over X square. I'm writing FPQ now. Equals FRQ. FRQ, what's that? K times Q square over D square. So now I can just cancel Q square here and K cancel each other. What is left? 9 over X square equals D, 1 over D square, sorry. 1 over D square left. So 1 on top left, 1 over D square. So X square equals 9D square. And then square root each. X equals 3D. X equals 3D. We are getting, so it is negative and 3D. Positive and 4.5D? No. Positive and 3D? No. Negative and 4.5D? No. Negative and 3D? Yes. Answer is D. I hope it is clear. So we must just continue step by step using Coulomb's law and getting answer. So let's continue with next one. 1.9 is question. It's tricky question. It looks easy, but try. You have 30 seconds for this question. Electric circuit question. A voltmeter has a 0 reading if it is connected between 2 points. FG, EG, GH, DH, oh sorry, ED, FG, FH, or GH. Which one? Please try. You have 1 second. If you need extra time, you know what you are gonna do. So question 1.9. Which voltmeter, which point, if I use my voltmeter, you know voltmeter always connect in parallel. So let's use this voltmeter. Yes, our voltmeter is coming now. This is our voltmeter. I'm gonna take this voltmeter and connect to ED, FG, FH, GH. Which one is giving you 0? Let's try. ED first. Okay, I'm gonna use point E. And we can make it longer conductors, it's fine, between E and D. If I do this, which components, I'm just measuring voltage for which component? As you see, voltage for battery, voltage for cell, let's say, because it is single, voltage for cell. So because of that, you cannot get 0. Is it clear? So ED is gone. You cannot get 0 for that because you are measuring just like this one. You know, voltmeter connects in here. What you are going to measure? You are going to measure voltage for battery, voltage for cell. Yes, let's say cell. Because battery, 2 or more cells coming together. I was teaching grade 8, 9. Yeah, just voltage for the cell. It is same thing because this point here or there, it's the same thing because there is nothing, no component or point this one or coming to D. It is same thing. All right. Because of that, ED is not getting 0. We are looking for 0 voltage. We did try with ED, but it is not. And then FG. Okay, let's try FG now. Okay, from F to G, I'm just adding voltmeter. It looks tricky, but okay, FG. FG also not giving 0 because F is here. Just carry on from F. As you see, there's no component, nothing. Just like point E, it's coming here. It's this point. And then when you come this side, carry on, come, this side, come. Finally, you just coming here. As you see, you have cell here. One more time. It is same thing, just like using your voltmeter on the cell or using like this long way. Okay, you can say, why not FG here? You are measuring, it's the same thing, all right? So you are not, because you have switch here. If you don't have switch, everything will be different, but now you have open switch. Yeah, let's say open switch. So you are getting, yeah, let's say you are not getting 0. You are getting voltage for cell. FG also gone. Let's continue with next one. I'm sure you know answer now. FG. Okay, if you take FG, voltmeter for FG, I'm drawing voltmeter for FG. For FG, if I start from G, carry on. Okay, you stuck here. You cannot continue anymore. You cannot go to battery now. So just you should stop here. And when you come this side, you are going this way, but you have incomplete circuit. So you cannot continue that way because of this open switch. But what component you have between F and G? Component R. And what is current for the system? I. So I equals 0. Why? Because I know we have open switch. So V equals 0 times R, and then you are getting 0 voltage. I hope it's clear. So because you are just measuring voltage on R, current is 0. Because of that, voltage also 0. Let's continue with next one, GH. Now, GH, you just check for GH voltmeter on like this one. It is also same process. Just continue here. It's coming to cell. This one also coming to cell. You can say it's resistance here. What's going on? There's no current here, so you can just ignore it. You can just carry on and come here. This is not 0. This is voltage of battery. Same thing. All right, it's taking time. Huh? Tricky questions taking time. Let's continue with next one. Last question for today. Please try. You have identical resistance, X and Y, and then you have identical battery. Let's just double check. All light bulbs are identical, yes. EMF of batteries, same, okay, yeah. Same batteries, same resistance, but different connection. What they ask you, the power in bulb X is P. What is power in light bulb Y? Okay, so they were busy with X and Y. Okay, please try. You have 30 seconds now. What is power on Y? If power on X is P, what is power on Y? This is our question. Just check. Let's continue. When time is over, we are going to answer this question and then we have done for today. I hope it's going to help you, this lesson. These lessons will help you. Just go, yes, we can just remove it. Yes, let's continue. All right. So, for this kind of circuits, what we know? We know we have same current and they are sharing voltage. They are sharing voltage. We should remember for this kind of circuit, same current and sharing voltage. If you have 2 volts here, they are sharing by V and V. And write it down again. And then in parallel, what we have same voltage. Very important. We should remember. And then they are sharing current. So if you have same resistance, also current also will be same. But if you have different resistance, current will be different. But voltage always same. All right. Please remember that. So just use this information. If I say 2V for battery, why I'm saying 2V? To make it easy. So you can say another. You can give another number. It's fine. If you have 2V, they are going to share by these 2 resistance. So voltage for X is V. Voltage for X is V. Okay, that's right here. Voltage is V. And voltage for other one is also V. They are sharing voltage. We don't need this one, just right. So when you come this side, in parallel, we have same voltage, 2V and 2V. I hope it's clear. So from now, I'm looking for power. What was the power formula? Power equals current times voltage. But what else we know? We have same resistance. Let's say R. We have R for X, R for Y. So let's calculate with X first. For X, what we don't know about I, so we can write for I, can write V over R. So V over R for I times V. So power for X, P, it was P, right? P equals V square over R. Okay, just keep it here. And then let's continue with Y. So for y, what we have, power equals, just use this, okay, power equals current times voltage. This is our formula first. And then for y, what is our current? 2V over R, right? Because voltage is 2V. So 2V over R. What is voltage for y? Also 2V. You can write 2V. And writing 4V square over R. What we know about this? This is power of x. So if I say power for y, let's write y here. Y. So 4 V is equal to P, so you can write 4P then. All right, 4 times. You can, if you say it is difficult for you, P, Y, what's going on, you can use numbers. You can just give as just numbers. Let's say you have 10 volts here. Okay, and then you have 10 volts for battery. And then let's say we have 1 ohm. To make it easy, use just 1 ohm resistance. Resistance equals 1, and then resistance equals for y also, let's say R is equal to 1 ohm. What is voltage for X? 5 volts, because sharing by these two. 5 volts we have, and then for this side, what we have? We have 10 volts, because voltage is not sharing for parallel, they are equal. Now, so let's calculate for X first. Even I can get current now. What is current for this? From Ohm's law, V over R. V is 5, R is 1, and then 5A. So current is 5A. So power equals I times V. Current is 5, and then 5A, yes. Voltage is 5. So P equals 25 watts. You know that, unit of power. Just giving numbers. For this side, what's our current? 10 over, so let's use Ohm's law, V over R, 10 over 1. Current is 10A. So current we know, voltage we know. We can calculate for PY, current times voltage. So just use formula PIV first. Okay, let's write PIV first one more time. This is our formula. And then PY equals, what's our current? What we calculate? 10. 10 times. Voltage is 10. And then what I'm getting? 100 watts. So how many times bigger? 4. Because 25 to 100, we should use 4 times. This method also you can use to answer this kind of questions. Good luck. See you next lesson. We are going to continue with long questions next lesson. So today just we answer multiple choice questions with you. And then next period we can carry on with other questions, long questions. Our answer is D. Thank you very much. See you next lesson. Please stay with us. Don't forget to something. You know what you are going to do. All YouTubers are saying something, but we are teacher. We are forgetting to say that. But you know what you are going to do. Thank you very much. See you next lesson. Maybe my son will say something. What we are going to say.
Don't forget to like and subscribe to this video. Thank you.